Section 2 homework. Here we go. So, electric field and particle accelerator machine. So it has that. So that's the electric field strength. So E equals 4.5 times 10 to the fifth newtons per coulomb. How much work is done to move a proton 25 centimeters? Okay, so that distance is 25 centimeters. Remember, 2 to the left, so that's actually 0.25 meters. All right, so we've got a proton, so that's a, 1e, so that equals 1 times 1.602 times 10 to the negative 19th coulombs. All right, and we want work. So work equals QED, that equals 1.602 times 10 to the negative 19th, times 4.5 times 10 to the 5th, times 0.25. So our work here equals 1.602 times 10 to the negative 19th times 4.5 times 10 to the 5th times 0.25. 1.80 times 10 to the negative 14th joules. What we end up seeing there. All right. Next one. Ooh, 3-charge system. Okay, first charge is a 10e. Second charge is an alpha, so that's a 2e. Third charge is a negative 9e. All right, the distance between the first and the second is 1.05 times 10 to the negative 8th meters. So that's between there and there. All right, between these two, it's 5.05 times 10 to the negative 8th meters. All right. So then we want to find the force between 1 and 2. So that's 1, that's 2, that's 3. All right, so the force between 1 and 2 is going to be our K, 8.99 times 10 to the 9th, that's K. Q1, which is that 10 times 1.602 times 10 to the negative 19th. All right, so that's Q1. And then Q2, which is the alpha, 2 times 1.602 times 10 to the negative 19th. All right, all of that is over the distance of 1.05 times 10 to the negative 8th squared. Don't forget the square term, okay? 8.99 times 10 to the 9th times 10 times 1.602 times 10 to the negative 19th times 2 times 1.602 times 10 to the negative 19th. All that divided by 1.05 with parentheses around it, negative 8 squared. All right, so I got here my f of between 1 and 2 is 4.19 times 10 to the negative 11th newtons. All right. Force between the second and third, so F23. All right, so that's still going to be 8.99 times 10 to the 9th. This one now, 2, is still that alpha, 1.602 times 10 to the negative 19th. This is that negative 9 times 1.602 times 10 to the negative 19th. All right, divided by the distance over there, which is 5.05 times 10 to the negative 8th. Again, squared. All right, 8.99 times the 9th times 2 times 1.602 to the negative 19th times negative 9 times 1.602 times 10 to the negative 19th. All that divided by parenthesis 5.05 times 10 to the negative 8th squared. All right, so my force between 23, or between 2 and 3, is going to be negative 1.63 times 10 to the negative 12th. Negative 12 newtons. All right, so, whoops, undo that. That's what I wanted to do. All right, net force and direction of the second charge. Okay, so between 1 and 2, we've got both positives. So because they're both positives, these are going to repel. All right, that means this one's going to push it this way, this one's going to get pushed that way. All right, these are going to attract, which means this one's going to get pulled in, that one's going to get pulled to the right, So because of that, oh my goodness, this is such a bad arrow, sorry. Because of that, we know that both of the forces are acting the same direction. So our net force, remember, this negative here just means attraction. It doesn't mean direction. So we're going to take 4.19 times 10 to the negative 11th, and we're going to add 1.63 times 10 to the negative 12th. All right, because they're both acting the same direction, we're going to add those both together. So 4.19 times 10 to the negative 11th, I'm going to add that to 1.63 times 10 to the negative 12, and we see 4.35 times 10 to the negative 11th newtons, and it's going to be to the right. All right. Oops, sorry. To the right. Okay, and again, the reason we added those together is because they're both acting the same direction. All right, last one. Move an electron with that. Okay, so my Q equals negative 1.602 times, and let me make sure I do that better, sorry. All right, negative 1 times 1.602 times 10 to the negative 19th coulombs. Uniform electric field, so that means my E equals negative, oh, that's the force, not the E. Sorry, I almost got caught up in that one. So my force is 1.25 times 10 to the negative 12 because it's newtons. All right, what is the magnitude of the electric field strength? All right, so we're looking for E there. All right, so our force equals EQ. So 1.25 times 10 to the negative 12 equals E times negative 1.602 times 10 to the negative 19. Divide both sides by that, times 10 to the negative 19. Big E equals 1.25, 10 to the negative 12, divided by 1.602, 10 to the negative 19th. This should be negative 7,802,000, 746.6. And that's going to be newtons per coulomb. All right. Let me know if you got questions.